This is 5.3, which is sinusoidal functions with transformations. So what I'm going to do in this video is I'm going to take the original sine and cos graphs. I'm just going to throw a bunch of transformations at them, and then we're going to graph them and see what they look like. Now in a separate video, I'm going to do some other examples. So if you want to check out those examples, you can definitely click on that link later on. Okay, so let's get started. Here we have the sine graph, it's in red, and then the cosine graph, it's in green. Okay, so the sine graph goes right here. That's one cycle at 360 degrees, and then we're just going to repeat it. Okay, and then we got the green one, which is the cosine graph, and it also has a period of 360 degrees, and I don't know why I just decided to draw another cycle as well. Okay, now since this is advanced functions, I'm not going to write 360 degrees, I'm going to write it in radians, which is 2 pi, the 360 degrees equivalent. Now the amplitude is the distance between one of the peaks, like one of the tips, to about the middle of the graph. Okay, so you could also go one of the tips to the middle of the graph, and notice that that distance from a tip to the middle is about 1 right there. Okay, it's the same for the red graph, because here is one of the peaks to about the middle of the graph. Okay, and that again is a height of 1. If you really wanted to calculate it instead, you could always take your max minus the min, get your answer, and then divide by 2. So I think we've discussed this before in a previous video. Let's move on. All right. Here are a bunch of transformations that we're going to add on the original two graphs. So the original two graphs had the sine x, right? So if I go back here, see sine x, and then you got your cos x as well. So what are all these other letters? Well, you've learned this before in grade 11 where you've had, you know, those vertical translations and vertical compressions and reflections and all that stuff. Well, it's exactly the same. Okay, you have your A right here and your C right there. Those guys are your vertical components. Okay, you got your vertical stretch or compression, you got your vertical translation, your up and your down. Now you also have horizontal components, which is the K and the D. The K is your horizontal stretch or compression, and then you also have your D, which is your left and right. That's your horizontal translation. Okay, now where do the reflections come in? The reflections come in when either your K or your A are negative. Then you got those reflections over your axes. Okay, so nothing has changed since before when you were talking about parabolas, square root graphs, and so on. Now, remember your period of 360 degrees? Well, that might stretch or compress depending on your K value. So this K value is going to be important when you're talking about the period. The height of that middle, the peak to say the middle of the graph, remember the amplitude, that's going to change if this A value decides to stretch or compress your graph vertically. Okay, so these two guys are going to be very dependent on your A and your K value. So what we're going to do is we're just going to sketch you could always sketch the original with maybe some stretches and compressions first and then reflections. Then your final sketch should include the vertical and horizontal translations. Okay, now they call the horizontal translation, your left and your right, something completely different. Okay, so don't get phased, phased by your phase shift. That was really corny. Okay, so vertical translation is your up and down. Your phase shift is your left and right. Okay, so that's what we're going to call it. Now, the way that I normally graph these is I actually don't do all those graphs. It's so much work. I actually just do mapping notation, which I'm going to show you. Okay, so here is a cos graph with a bunch of transformations. Okay, so what we're going to do is we first need our x and y values of the original cos graph. So these are the 5 major points of the cos graph. Here, let me show you. Okay, so the cos graph was green, remember? So 1, 2, 3, 4, 5 major points of the cos graph, and all I did was I just wrote them right there. So these are the original numbers. Now what I'm going to do is I'm going to start my transformations. So remember, your A and your C value, those are going to be your vertical components. So I'm going to put that with my vertical numbers. y is vertical. And I'm going to put them exactly as it's seen right here. So if it says -3 and a +1, I'm going to put a -3 and a +1. So all of my numbers here, I'm going to multiply by -3 because, I mean, this -3 is multiplying the cos, okay? And then the +1 goes at the back. Now what about that 4? Well, that 4 is right in front of the x. It's your horizontal stretch or compression. Now, the thing that happens is with your k values and your d values, they're going to be the opposite of what you might think. So instead of putting a 4, I'm actually going to put in a reciprocal, a 1/4. Okay, so we're going to go 1/4 times x instead of the 4. All right, I'm going to calculate all my new numbers. Here we go. And look, 1/4 times 0 is 0. 1/4 times pi/2 is pi/8. Now you'll notice that I've started to make an equivalent fraction over here. So 1/4 times pi should have been a pi/1/4, or pi/4. But it'll make it easier for you to graph later if all your denominators are the same. So I just doubled this 4 and I doubled the top as well. So 2 pi/8 is going to make it a lot easier to graph, and I'll show you why. Okay, now I also calculated all my new red numbers, and I'm going to graph, and I'm just going to scroll down so you can see it right there. So do you see how these are all 8s on the bottom, the denominators? I took 1 pi and I made 8 sections. 1, 2, 3, 4, 5, 6, 7, 8. Do you see that? So every single section is an 8th. Then all I have to do is I just count. So 0, -2, okay, 0, -2 is right there, okay, and then 1 pi/8, 1. 1 pi/8, and then 1, okay, see this one? 2 pi/8, and then 4. So you're just going to go 1, 2 pi/8s, and then 4. The next one is 3 pi/8s, and then 1. So 1, 2, 3 pi/8s, and then goes up 1. Do you see that? It's so much easier than if I had a different denominator. Okay, so this guy at the bottom helps you to figure out how to break up the scale on the x-axis. So all you do is you just take pi and you just break it up into 8 pieces. All right, let's check out another example. Okay, so here's one that's a little bit more difficult. The reason why it's more difficult is because they're trying to trick you. Here's your k value right here. Okay, your a value is 1, right? There's an invisible 1 there. And then there's a 0 at the back for your c value. Now the trick is this guy is not your d value. Okay, remember, you're going to have to take this guy and you're going to have to divide it by whatever is here in yellow because this guy always gets factored out. Okay, if I go back to, let's see, it was this one right here, notice that there are double brackets. So your k has to be alone. There has to be brackets so that there's x by itself and your d in there as well. All right, so let's go back. Okay, so I took this guy, I divided it by the 2, which means I factored out a 2, and that's what's left over. So it looks like it's going to the right, pi/2, but it's really not. Okay, so this is a major mistake that a lot of people make on tests. So there's your pi/4. All right, okay, so here are all the major points on a sine graph, the 5 major points that make up the sine graph. So again, let's compare all your vertical to your horizontal components. The vertical components, well, there really aren't any. So this guy's going to stay exactly the same as it was. Now your horizontal components are going to be the opposite of what you see. Okay, so instead of taking a 2 and multiplying, you're going to multiply a 1/2, so the reciprocal. Instead of putting a minus pi/4, you're going to put a plus pi/4. You're going to calculate all your new numbers. Okay, now remember, this guy right here, 1/2 times pi/2 plus pi/4 is actually pi/2, but I decided to make all the denominators the same so that it's easier to graph. I just doubled the 2 on the bottom and doubled the pi on the top, so you get an equivalent fraction with the same denominator of 4. Now all your y's are exactly the same as before. All right, now the graph is right there. Okay, so I took my pi and I split up this section into 4 pieces. Okay, so you got 1, 2, 3, 4, and I'm just going to graph it. So pi over 4, 0 is going to be 1 pi over 4, and then at a height of 0. The next point, 2 pi over 4 and 1. So 1, 2 pi over 4s, and then at 1. And then let's try one more. Here's 5 pi over 4 and 0. So let's plot that point. 1, 2, 3, 4 pi over 4s and 5 pi over 4s, and then it's at 0. So I put a dot right there. You guys getting it so far? So if you want to check out some more examples, just take a look at the next 5.3 video. Okay, see you later.